Hi, so in this video, we are going to discuss the force between the parallel current carrying wires rather. So here you can see that this is the wire W1 and this is the wire W2, and they are carrying the current I1 and I2, and the distance between them is D. So with the help of this diagram, by the end of this video, we will be finding the value of force between both the wires having some current going on in the same direction. We can clearly see from this diagram that the current is moving in the same direction. So let us consider the small element dl. So I have here already written the small element current carrying element dl, and so the magnetic field at dl due to the wire w1. So I'll begin like that. So yes, so magnetic field at dl due to uh, due to the wire w1, due to the wire w1. So that is going to be b is equals to uh, mu 0 I1 upon 2 pi d. So this is equation 1. So in now the field due to the portions of the wire W2 above DL is 0. So equation 1, it gives us the net field due at DL. So this gives us the net field at DL, and the direction of this field is perpendicular to the plane of the diagram. So here there is a cross, so the field is basically going perpendicular. Like if you have your phone on the surface of the table, and if you are pointing a pen perpendicular to it, so yes, that's right, that would be the direction of magnetic field, which is going inside the plane of the mobile phone which is lying on your table. Okay, so yes, the magnetic force at the element dl. So at this particular element, what will be the magnetic force? So I'll be writing that magnetic force at the element dl. So that is going to be df is equals to I2 dl across b. So why we have taken I2? So this is the element dl, and there is I2 current which is flowing. So that is why it will be I2 dl cross b, like whatever magnetic field it is experiencing due to the wire W1. So let us call this out to be equation number 2. Now we will be putting equation um, 1 in equation 2. So I'll just simply write down that putting equation uh, equation 2 in equation 1. Okay, so that will give me df is equals to df is equals to, so I'll just go back and see what I have written here. So I2 dl remains as it is, and I'll be putting the value of b, and sine theta is like the angle between magnetic field and dl. So here it is going to be 90, as you know the magnetic field is going in the plane of the paper over here. So sine 90 would make it as I2 dlb, just I2 dlb. Okay, so I'll just write down I2 dlb. So what is dl? like what is B here? So B we have already taken here. So that is mu 0 I1. So I'll just substitute mu 0 I1 upon 2 pi D. So overall that will give me df is equals to mu 0 I1 I2 upon 2 pi D into dl. So then that would give me df upon dl, which is equal to mu 0 I upon 2 pi d into like mu 0 I1 I2. So this is going to be mu 0 I1 I2 will come. So mu 0 I1 I2 upon 2 pi d. So basically this is the equation number 3. Okay. So this is the value of force for that particular current element dl. Okay, so now if the wires, you can clearly see that here the wires are carrying current in the same direction, but then if they are carrying current in the opposite direction, then the wires will start repelling, like there will be a repulsion, and then maybe the equation would be, so for we can write wherein wires are attracted. Okay, so wires are attracted to each other. Okay, wires are attracted due to current in same direction. Okay, but then instead we can also write df upon dl. Okay, so that is df. So yes, that is df upon dl is equals to minus mu 0 I1 I2 upon 2 pi d. So why are we writing minus? What is the reason of writing minus here? Because the currents are in opposite direction. So in such cases, the wires repel each other. So we can write that uh, parallel wires carrying current in opposite direction, they repel each other. Yeah, so we can come across many such numericals in which we can have two parallel wires, and if we are given the direction of the current, like both the currents, if they are in opposite direction or a similar direction, then we can identify whether there is a repulsion, force of repulsion or force of attraction between both the wires. So you can add these formulas in the list if at all you are making any list for your preparation, and this equation will be helpful to you to solve many such numericals. Okay, so thanks for watching. I hope this video is helpful to you. I will see you in the next video. Bye bye.